when differentiating different functions or different expressions, you might see this ddx symbol as a sort of operator that you can apply to a function. And you'd be right. It sort of is an operator that you can apply, similar to multiplication or division, or maybe the power rule or the exponent rule. So this exponent would distribute off to each of these functions, right, as like separate variables, you could think. So f of x to the n times g of x to the n. And similarly, some of you might also think that this ddx operator would also distribute onto each of these functions, right? And that would make this equal to f prime of x, g prime of x. Well, if this is true, let's test it out. So f of x is equal to maybe x squared, g of x is equal to x cubed. Okay, so the derivative of x squared times x cubed would be equal to 2x times 3x squared, which is equal to 6x cubed. Straight off the bat, this might seem weird to you, right? And that's because, well, it kind of is. It is weird. If I were to take the derivative of the simplified expression, x to the fifth, right, I would get 5x to the fourth. So this is not true at all, not true. Okay? So we need a new rule. Let's use the limit definition of a derivative to solve this, or to try and derive the product rule. So you might see right over here that this is just one combined function in a sense that we're taking the limit of as h approaches 0, right? Here it's of x plus h. So let's try and rewrite this numerator a little bit, right? Just the numerator for now. So f of x plus h times g of x plus h, right? That's straight from here, minus f of x plus h times g of x plus f of x plus h times g of x minus f of x times g of x. You might be thinking, where exactly did these two terms come from? And well, you'd be right for thinking that. They came out of nowhere. I just made them up, right? But it'll make it easier to manipulate these expressions later on to get the limit definitions that we're chasing for. So if I were to factor this out, this f of x plus h, I would be left with g of x plus h minus g of x. Are you starting to see what I'm getting at now? Right? And let's remember this is all over h over here. So this is all over h, right? And this is all over h here, but let me write this out. So g of x times f of x plus h minus f of x, all of this over h, right? If I were to take the limit as h approaches 0 of these two, you could see right away that this is the limit definition of a derivative for g of x here and for f of x here. So this would come out to f of x, remember h is approaching 0, so this will also approach 0, times g prime of x plus g of x times f prime of x. There you go. That's your answer. That's your formula that you have to memorize. All right, so we went from this monstrosity over here all the way to this relatively simple formula for the product rule. All right, let's try an example here to really soak this in. Let's do x squared times e to the x. Quite easy to take the derivative of, but not as easy to graph probably. If I were to use this formula as a way of visualizing it, you could see this x squared as f of x and this e to the x as g of x, right? And this would end up being equal to x squared times the derivative of e to the x plus e to the x times the derivative of x squared. And we're left with x squared e to the x. Derivative of e to the x is just e to the x plus e to the x times 2x. And if we wanted to go further, right, to factor it out, we could leave it off as x e to the x times x plus 2. And this would be your final answer.